This video will be going over Part A of the Google Sheets activities, scatter plots, correlation, regressions, residual plots, and outliers. So please start by opening the Google Sheet titled Groovy Google Sheets Scatter Plots from Google Classroom. For this part, there are three formulas you'll need to know. One for how to calculate the correlation coefficient and the slope and the y-intercept. And just note again here where it says x variable and y variable, you don't actually type in those words. What you do is actually just highlight the cells that contains that data. So don't type in y variable, highlight the column or the data that has the y variable, and same with the x variable. So for part A, I'm going to show you how to make scatter plots and perform the regression, which means the line of best fit, and calculating the correlation. So the data here in the McDonald's sheet shows the amount of fat in grams and the calories for 29 McDonald's sandwiches that are shown. So right here. So to make a scatter plot, you're going to highlight columns A and B. So just highlight the whole column, and from the insert menu, select chart, and it's going to do its smart thing and assume that you want a scatter plot, and it's called a scatter chart in Google Sheets. If you don't get a scatter chart for some reason, you can just under chart type scroll down and select the scatter, and it would, right there you can select the scatter if it's not shown automatically. Now we've got to format it. In the Customization tab, you're going to give it an appropriate title. So under Charts and Axis. Now the chart title is always the y variable versus the x variable. So it's going to pretend it's smart, and it'll probably give you that title automatically. If not, retitle it so it's always the y versus the x. You're going to want to title the horizontal and vertical axis with units if needed. It's already done because it was written up here. But again, if you need to, under here, you can click on horizontal axis title or vertical axis title and either change the title or add the units, whatever is needed. Now, you are also going to either keep the legend if there's one showing, or in this case there isn't one showing. We're going to need a legend because the legend is where the equation of the line of best fit is going to be. So under legend, you need to have one showing. And you can put it wherever, but I'm just saying if you put it at the bottom. Right now it'll just say calories, and like I said, later on, that's where the equation of the line of best fit will go. There's other things you can do. You can change the size, the shape, and the color of the points. And you do that under series. So here you can change the color of the points. You can change the size if you want them bigger or if you want them smaller. You can also change it so that they're not circles. You can change them to be a different shape, to be anything like this. That might be something that you want to do if you are making more than one scatter plot. Make one of them one color and another one another color, but we'll get into that in one of the other parts. You can also add, change, or remove grid lines. So under grid line, major grid lines just means how many are you going to see automatically. They do set a default number, so the 1, 2, 3, 4, 5 is what it's set at. If you want to see more, so we can change that to 5 grid lines. If you wanted to change it to like 10, so that means it'll change the scale here. It makes them a little bit thicker. If I change that back to 5, minor grid lines would be how many we see in between the major, And if we added minor grid lines, then they're not quite as bold as the bigger ones. You can also change the color, so the major ones could be a little bit darker, just things like that. Now that's on vertical. On the horizontal, you can also change the number of, so we've got 1, 2, 3, 4 so far. If you wanted to change the number of grid lines on the x-axis as well. So that's changing some settings. Before we move on, I'm just going to change these back to default. You don't have to, but I'm just going to do that. Just so that it matches the picture. Alright, now to get the line of best fit, you're going to go to Series, and you're going to click Trend Line. Trend line is their name for line of best fit. And there's different trend lines you can do. We're going to make sure that it is linear. Linear should be the default, but there's lots of different ones you can do. Again, you can change the color and the thickness and things like that. In the label drop-down menu, you're going to select Use Equation. And there you can see the equation. Now, they don't put the y equals. If you were doing a test or something, make sure you add the y equals. So this is y equals 14.9x plus 149. Now, the very important thing is that do not click Show R squared, because R squared is not the same as R. It literally is R squared. So if you were to show R squared is 0.85. What you could do is just take the square root of that to get R, but we'd rather just not show it at all, and I'm going to show you later how you actually can calculate the value of R. And the other thing you might want to do is change the scales. Like you can see here, it kind of decides what your scale should be. If you want to change your scale, you're going to click on either the horizontal or the vertical axis section. So under horizontal, you might actually want your minimum to be 0. And if you wanted to change your vertical axis, you could go here to vertical. If you had a lot of wasted space down at the bottom, in this case it's not too bad, but if you had a lot of wasted space, you might want to change your minimum to 200. Or sometimes if you're extrapolating, you might want to increase your maximum. That's how you do your scales is up to you. Just remember you want your graph to take up about 2/3 of the grid. Alright, we're done with the graph, so you can click off the chart editor. Now, when they talk about regression, just remember here, a regression analysis measures the relationship between two quantitative variables and calculating the correlation coefficient. It is widely used for predicting and forecasting values using the least squares line. The least squares line is what they call the trend line. It's the same as the line of best fit. So if they talk about regression, that is the act of making the line of best fit and determining the correlation. So now we're going to determine the correlation. So in cell E1, we're going to calculate the correlation coefficient. So remember the formulas up here. For the correlation coefficient, it's equals CORREL, bracket, highlight the y variable, comma, highlight the x variable. So in cell E1, we're going to type equals CORREL and open a bracket, and we're going to highlight the y data. Then press comma, and now you're going to highlight the x data. Remember, it's the dependent or the y first, and then it's the independent. And remember, if it's a long list, you can just click on the first cell, press Control Shift and then the down arrow key, or for Macs, Command Shift and the down arrow key. And you can close the bracket, but if you press Enter, it'll automatically close the bracket for you, and that will give you the value of the correlation coefficient. So we have a very strong correlation here. Now, remember that here it gives you the equation of the line of best fit, but it does a lot of rounding. So sometimes you want something that's a little more specific, so a more specific slope and a more specific y-intercept. So also, sometimes you want the equation of the line of best fit, but you don't want to make a scatter plot. And in that case, you can get the slope and the y-intercept just using the formulas that are on the previous page. So the formula for slope is equals slope, open the bracket, highlight the y data, comma, highlight the x data, then press enter, and that gives you the slope. So you can see it's the same number here. To get the y-intercept, the formula is equals intercept, open the bracket, highlight the y data, comma, highlight the x data, and then enter, and you can see that the y-intercept is the same as there. So just remember, the advantages of doing this is that it gives you numbers that are more precise because these have been rounded. Also, doing this would allow you to get the equation of the line of best fit without having to make the scatter plot. And if you wanted the line of best fit, then it would just be, if you were writing it down, y equals this number, the slope, times x plus the y-intercept. So if you wanted to figure out some interpolation or extrapolation, so if the McLobster sandwich had 9 grams of fat, and we wanted to use the line of best fit, you can do the calculation down here in this space. So if you wanted to find out the number of calories, that's y. Always make sure when you're given this piece of information, you know if this is the x or the y. This is the x. So if you were to do on paper, you would take 14 point, and this you could round a little bit, 898 times 9 plus 149.39. Or you could actually do that in sheets. So you could say equals the slope times the value of x, which is 9, plus the y-intercept. So you would get that the number of calories in the McLobster, according to the line of best fit, would be about 283. So that's calories in McLobster. And in reality, the McLobster has about 300 calories, so we're not that far off. So that concludes part A, which just shows you how to find the equation of the line of best fit, make the scatter plot, and calculate the correlation coefficient.